if you get taught something in maths, you should be able to say, oh, I remember doing this guy, same sort of stuff, over in that subject. Let me have a quick look at my notes and I check, oh, yes. And then you move on. All right, let's move on. Let's move to the board. All right. Analytic and harmonic functions. Could you pin my board so I can, let me see if I pin it myself. Ah, better. It just helps me see what you're seeing. All right. All right. It's not the best, but it's best what we got now. Analytic means CR equations. Again, I keep writing them down, and if you keep writing them down, all of a sudden they go in your head and you realize that you don't have to worry too much. This means, sorry, never start with that. Always start with, that means f of z is equal to u of x and y plus v x and y I. And this also means that you differentiate du dx is equal to dv dy. And now you're going to turn them around, turn the top around, or you want to turn the bottom around, it makes no difference, and then change the polarity. So I like to do change bottom. And that's what analytic means. It means CR equations, bloop, bloop. Now, if I say to you that it's analytic and I give you only this part, then this lesson is going to show us how we get to this part. So, given, how do we find that? Or vice versa, the same method. Second part is harmonic. Implies Laplacian. And that means the del operator, yeah, on my function, del squared is equal to 0. What does that mean? Del of my x of both the output. Now, if that means 0, copy that down because I want to put this up there. Copy that down because I want to do more with this. I just realized that I'm going to do more explanation. I better smooth explanation. So copy that down so I can rub it off and then go to that. And when you're done, let's give me a shout.
Finished, Kwame?
Finished?
Yeah, I'm not sure if Kwame is finished.
Is it finished?
Yeah, I'm finished.
I know you're finished. I don't know if he's finished. Kwame. Kwame.
You can take it also. Sorry.
All right.
I didn't realize it was mute.
All right. So let's just So we're going to look at a question with that and this. This is the lesson today. It's two questions. But the first one is really easy. The second one is a little bit more trickier. So, you know, I was telling Anthony that I had planned to start the tricky one. But if you go the tricky one and they don't get it, you know, you soak them up. Give them something that you know they'll get, and then give them a slightly harder one after. And that's an old teaching trick. All right, so harmonic implies and is implied by Laplacian. And that means if your function is f of z is equal to u of x and y plus v of x and y, these are the output functions. So you put, and because I put z there, really I should put x and y for consistency. X and y input, x and y output, x and y imaginary output. What we're saying is del squared of f of x, y is equal to 0 plus 0i. This means that del squared u dx squared plus del squared v dy squared. No. I keep writing it wrong. It's not that. It's this guy is equal to 0. Plus this guy is equal to 0. So, it's an important thing that the del squared operator on a harmonic function means both when you differentiate this guy, apply the del squared operator on here, it's equal to 0, and here it's equal to 0. And the reason why I changed the way I wrote it, because I want to re-emphasize something. For a complex number to be equal to 0, or for the output of a complex function to be 0, the real part must be 0, and the imaginary part must be 0. So let me write this guy equal to 0. So this is harmonic, implies that. So analytic, Cartesian, harmonic, Laplacian. That's what we're doing today. Sorry for using the red pen, but that's all I got. I'm going to rush out after this. I'm going to get a different color pen. Alright, I think you copied it down.
Got it, sir.
You got it? What about calling?
Yes, so you can take it off.
Alright. So let's go back to analytic functions. So here's the question. Given f of z is equal to, sorry, my bad, f of xy. Now, the reason why I'm saying xy is is because the outputs are going to be x and y, and this is going to be x and y. X cubed minus 3xy squared plus 3x squared y minus y squared I. My pen is not giving me a good run, so I'm going back to blue. Blue is slightly better. And the first part is 1. Show that f is harmonic. Oh, I messed up the question. I've messed up the question. That's okay. That's okay. You're going to use this, and I'm going to show you that given this, if it obeys the Cauchy-Riemann equations, then this, given this is analytic and this is u, I can show that this guy here is in fact v. So let me tell you what I intended. So I intended not to give you the v part, but that's okay because this is the dummy run. This is the one that's really easy to get it in your mind so you can understand. After we do this one, we can do a much harder one where I can take it out the book and you can use the same principles and go ahead. So let's do this. So show that f is analytic, harmonic. And part 2, verify that f satisfies the Cauchy-Riemann equations. So I messed up the question, but hey, strangely enough, I just adjusted the question and we're good. So basically, harmonic means if you differentiate this 2 times is equal to 0, and if you differentiate this 2 times is equal to 0. And this part means if you're given this, show that you can find this to be v. And the last part, which I don't know the answer to, is express f in terms of z, which is x plus iy. I don't know the answer to that. I don't have the answer to this. I know I can prove this and I can prove, but I don't know the answer to this. This is what I'm going to. I made the question up. You said, how do you make the question up? You'll get used to it. You'll get used to knowing how to do these things. So, harmonic, CR equations, expressing Z. We know what that is. So, you write it. Harmonic, part 1.
The top part there. I can't see too well.
You can't see too well?
The black ink.
That's okay. That's okay. Is that better?
Yes, sir.
Alright. So now this is a lovely, nice equation. It's lovely. And I'll tell you why it's lovely. Because, and I'm going to tell you, I'm not cheating. This is just f of z is equal to z cubed. Let me just turn around. is just Z cubed. And I'm going to assume that Z cubed is both analytic and harmonic. I just made the question up. Because I know Z squared is analytic and I'm going to Z cubed. So if we can work on this, where we know it's a nice, well-behaved function, and we can practice the skills that we want to practice, when you get given a harder question, you can say, oh, same principle, just a little bit more legwork, good to go. So that's the reason why I made the question up. I said, what can be analytic? Z cubed. You know it's Z cubed. I'm telling you Z cubed. But we're going to play like we didn't know and work it out and see what happens. All right? All right. This is harmonic. See how let's rub that up now, because we know what that is. Let's rub that up. So this guy is U. This guy is V. All right. So U is equal to x cubed minus 3x squared y. Differentiate. We want to prove that it's harmonic, right? Harmonic. This implies del squared U is equal to 0. What is del squared? Remind yourself. Now, you know, so I'm differentiating partial differential of U, so to x squared, and U to y squared. That's in 2D. I don't know if you've come across the Laplacian Anthony Cal 4 in 3D. So it's x squared, y squared, z squared. And then in the Navier-Stokes equation in fluid dynamics, you got x, you got y, you got z, and then you got time. But del squared operator and del operator. Del squared operator. In time, fluid dynamics. So that's interesting. So what? Interesting. Whoa. So let's differentiate this with respect to x. When you differentiate it with respect to x, y is a constant. Because look, this is x, this is y. Y. When I'm looking at a variable there along a line, my y value is constant. So I look at the variance along the x, my y has got to remain constant. All right, differentiate respect to x. That becomes 3x squared. And now I'm differentiating this with respect to x. So my y is a coefficient. So x just goes from x to 1. So 3y squared.
Yeah.
And I'm going to differentiate again with respect to x. This guy disappears, and this guy becomes 6x. And I'm going to rub out this space here now, because that's in our heads now.
Alright, right answer or just continue listening?
You can do it yourself if you want, but I'm going to do it on the board, so you can do it yourself. I'm going to go dv dx. Alright, you do it. You do it, dv dx.
Okay, I'm going to write that first and then do it.
Yeah. Du, sorry, not dv dx. Du dx. Du dy, sorry. And then du squared dy squared. So stick with, when you want to show that it's harmonic, pick u, differentiate it twice, add them, you're good to go. Then pick v, differentiate twice, add them, good to go. Then You want to show that they obey the Cauchy-Riemann equations. If you are given this, you should be able to deduce that. So we're going to do that after.
All right, so that's differentiate u respect to y.
Yep.
U respect to x. Differentiate u respect to y. Oh, so that will be that will be different u with respect to y. That will be 0. So that'll be negative.
That's 0.
Yeah.
And then that 2 comes down, becomes minus 6. Now I differentiate this guy again with respect to y. Is equal to minus 6x.
Yeah. Because that'll be x will be a constant.
Yeah. And then I add these together, I get 0. Therefore, del squared u is equal to 6x minus 6x is equal to 0. QED. Can I leave you to do this guy?
Yes, sir.
And then I come back and we'll verify that. And then, given this, how will we deduce this if they obey the Cauchy-Riemann equations? So I'm going to let you do V now.
So that is read. Therefore the second partial differential of u.
Therefore, del squared u is equal to this guy plus this guy is equal to 0.
Right. But del there is what? The second partial differential?
Yes. Del squared is del. The del operator is this guy. You did this in Cal 4.
Yeah.
And if anything I'm covering and you don't get it covered because you didn't cover anything in Cal 4, then it's your job to call Anthony on his night off or your night off and discuss how to do del, this and that, blah, blah, blah. Guess what? Your teacher better than me because he's your peer. I don't know what it is, he's a trained teacher. I don't know what it is peer to peer teaching, but guys, you guys know it better. I'm back in a sec. So do the V part and we'll clarify the board and then we'll go from here to here. All right, back in a sec. Strong one. All right, guys? Alright. Alright, so rub it up, dog, and then I'm going to go to this guy. So the second one now is V. V is equal to 3x squared y minus y cubed. The V part is the coefficient in front of the I.
Yeah.
Always. Don't include the I, it's just the coefficient in front of the I. So dv, dx, and d squared, dx squared. Let's write that down. And this guy, dv, dy, and dv, dy squared. Alright. So we've got another function. I'm going to differentiate with respect to x. This guy disappears, and this guy is a constant. This comes down.
6xy.
Is 6xy. And I'm going to differentiate this guy again with respect to x. I just get 6x.
6y.
6y.
6y, yeah.
Terrible, terrible. Alright. And now this guy, differentiate with respect to y. That's a coefficient. That differentiate. So that's 3x squared
minus 3y squared.
Minus 3y squared. And differentiate this again is
negative 6y.
That disappears, negative 6y. And then therefore, del squared dv, del squared v is equal to 6y minus 6y is equal to 0. QED. That's a lovely question, isn't it? It's nice, easy part, not complicated. Alright. Alright. Let's rub.
So
Go ahead.
So what we did a while ago was what? We're not finished yet.
We did that it is harmonic.
Okay.
Because we showed that the del squared of each of the functions, both u and v, equal to 0, so that u is harmonic and v is harmonic.
Okay.
Yeah, that's what it's called, harmonic. When you satisfy the Laplacian, it's harmonic.
Okay.
Now we're going to do something that I wanted to do, but I kind of messed up on the question by giving you v. But I can adjust my question. I can say, verify that given u, you can deduce that if it's Cauchy-Riemann, then the function v is in fact its counterpart. Where we go. This is something in Cal 4. So, given u equals x cubed.
So we're editing the original question.
No, we're doing the same question.
The second part was to verify that f satisfied the Cauchy-Riemann equation.
That's right. So I'm going to do it now. I'm going to give you this. Well, we've done that already. We're editing, you know, we're editing because we've done that. We did that by doing the Laplacian. Can you see it? If you look in your notes, you'll compare the du by dx is equal to dv by dy. You can verify that. Carmen, you there?
Yeah, I'm there too.
Okay. So, can you see that by doing the Laplacian, you verify the Cauchy-Riemann?
If you're speaking to me directly?
Yeah, I'm speaking to both of you guys. Can you see it?
Well, I was hoping to see it when you asked to continue, because the exam With the example, I'll be able to see it better.
All right. So if you go through your notes, you can verify that du by dx
is equal to
partial du by dx is equal to partial dv by dy. You can see that by comparing.
And then du
just box.
Then
and then the other one is minus. Just box. And away you go. So we don't have to verify counter remake because we inadvertently did it. What we're doing now is saying, given u, could we find v in this format? Verify that u deduces v. Yeah?
Okay.
Right, so it still be nice. So can we do it then and then give it to you then? Just to make
you want to do it?
Yeah, can we do the second part just to make sure that we're doing it the right way?
You've got it up there. You've got it in your notes. Let's just all right.
Du by dx equal dv by dy. Du by dx
And
is equal
dv
to by dy
dv
by dy
is equal to 3x squared.
Oh yes, it's equal. And then du by dy.
Yeah. Shown.
Du by dy
And then
is equal to dv.
U by dy.
Yes, it's there.
It's there in the notes. It's in the I messed up the question. That's what I say, no.
It worked out.
Yeah, I should have never written down the V part. So I had the question back and forth, but it's okay. We just see, oh, yes. So cartridge. So let's just do the last part. This is with respect to.
Yeah, it's equal to the negative, yeah. So
this guy, U, so that is 6 minus 6xy and dv minus dv dx is equal to minus brackets. Differentiate that respect to x, so this guy disappears and this guy becomes 6xy becomes 6x.
So we just write it back and just put shown and that verify.
Yeah, because I messed up the question. Yeah, I messed up the question, so
I don't understand why you think you mess it up so and it works out.
You don't understand?
Because it works out, sir.
Huh?
Because it works out, so I don't.
Yeah, but I messed up the order of the question.
Oh, okay.
You understand? You see, when I do another one, I'll give you a question out the book. You'll say, "Oh yeah, he did mess up the order of the question. Mess up the order." All right. What I'm going to do is I'm going to actually give you another question, and you work it out, and then we'll save the questions in the book for homework because they're slightly harder. Yeah, that's a teaching trick as well, Anthony. You
give homework the harder one for homework.
Yeah, the harder one homework, and sometimes the harder one, sometimes you got the answer in the book. Mr. Campbell does that. Got the answer in the book, but you have to show the working. That way, you know where you're going to head to, and you know it's a well ordered question, so you'd have no sweats. See, there's a lot of stuff that I learned from my colleagues. I like, why did you do that then? And I ask them, and they tell me,
Okay.
and I go, wow, and I go away and do the same thing, and it works. So that's a teaching trick in itself. Copy some of the tricks from your learn good ones and copy it. All right. So what are we trying to do now? We're trying to say, given you, can we deduce V? That's the question now. So, given this, given that the Cauchy-Riemann equations, so imagine Imagine we don't know what this is.
So what would you put there? You'd put a blank or something?
Yeah. Or even this.
You put x plus, sorry, v plus, yeah.
So we need to deduce that by given the counter-Riemann. So we're going to have to differentiate with one variable, integrate, and then balance back. So before we do anything, again, write down the counter-Riemann equations. Put them over here, nice spot over here. du dx is equal to dv dy, and du dy is equal to minus dv dx. Put them in a box.
Doesn't seem hard. You just have to get accustomed to writing the formula.
That's right. That's it. You know how many times I've written them since I introduced them? Even I don't, I keep writing them down. Hammer it in your head. Hammer it in your head. After a while, you realize that the first set is just the real differentiated real is equal to imaginary differentiated with respect to the imaginary part. Then when you cross, you get a minus sign. All right. So we need this guy. du dx is equal to 3x squared minus 3y squared. And that's equal to dv by dy. So now we're going to integrate.
Oh, that's where you're coming from. Do you I don't know. Because that's what we're told for the Cauchy-Riemann.
So now remember, when you're differentiating with respect to one variable, the other variables are constant. So when you're integrating with respect to one variable, the other ones are constant. So this guy now, I put a y there, 3x squared y minus 3y cubed over y over 3 plus p of x. Rightio. Back again, as is always the case. So now let's look at what we did here. Now when you integrate with respect to y, this guy is a coefficient, you get y. When you integrate that respect to y, you increase the power by 1, 3, and that becomes just y cubed. Now, you must add the constant in integration. But the constant of integration in partial differentials is a function of the other variable.
Question, sir.
Yes.
But did you need to really do the integral to find the other part?
That's what I keep telling you. I messed up the question. You're not supposed to know what V is.
I know, but remember the partial differential of u with respect to the y.
How are you going to get V? You don't know what V is.
I know, but we can use the formula.
What formula?
The Cauchy-Riemann.
Cauchy-Riemann. Yeah, but you still don't know what V is. You have to integrate.
But sir, remember that dy now is equal to the dv dx. The opposite, sorry, the negative of dv dvx.
Yeah, but you still don't know what the VDX is. Because you don't know V.
Oh, yeah.
You see, we don't know V.
Yeah,
That's why I say I can tell you I messed up the question by writing V down. But it don't matter because this is our first question. So I can adjust it and then you say, okay. I don't know what V is. Sure. Let's see if I can use that V is.
You will get dv dy and you will get dv, the negative of dv dx, but then you will have to integrate them.
Aye.
Put them together, integrate them to reverse it back.
Yeah. And then compare equations. And then you work out what P of X is. And then put that in and then you know what V is.
Yeah.
Alright, let's do it. Alright. So, V.
So
let's write it properly.
So
V
that.
What?
Okay, go ahead. Do what you're doing, sir. You're on the right track.
Yeah. V of X and Y is equal to this guy.
Yeah.
We don't know what P of X is. So let's rub this guy out.
Alright, let me write it down.
Yeah.
This is lovely.
But I have to do a nice simple one so you can get the idea. So that the method would actually, you know where you're going to end up. But that wasn't intentional.
Sorry about that, sir. I wasn't writing. I was trying to follow you.
That's okay. You know where you're going to go because I mistakenly wrote this down. But this is the genuine question.
I'm finished, sir.
Alright. Alright, let's rub out.
I got everything. I'm not sure if
no, don't rub out everything.
No, I got everything down.
Alright, so I'm going to rub this guy out. So I got V. Now there's another route to getting V. If you're giving U, if I differentiate that with respect to Y, So differentiate this with respect to y. This guy disappears, and this becomes minus 6xy. Is that okay? If I differentiate this with respect to y, I get minus 6xy.
Yes, sir.
And this guy is equal to this guy, minus dv by dx. Therefore, integrating minus dv by dx with respect to x now, P of x is uniquely a function of x. There's no y's in there. There are no y's in that function. Let's just remind ourselves. There's no y variable in there. Because when I differentiate this v with respect to x, with respect to y, that P of x disappears. Right? Integrate this guy with respect to x. This guy now becomes minus 6x squared y over 2 plus q of y. And I'm going to cheekily put in, therefore, minus v of x, y is equal to minus 3x squared is equal to minus 3x squared plus q of y. And then now I take the minus sign away from there. Take the minus sign away from there and put a minus sign there. And now I can compare my two v's. I see this is good, this is good. And I see that this guy is this guy and this guy is equal to 0. So v of x, y is equal to 3x squared y minus y cubed QED. Let me write this down. Comparing.
Okay, can you handle it? Put the screen down just a little bit. Just a little bit. Alright, that's fine. Finish, sir.
You finished?
Yeah, man.
Alright, I hope that's kind of clear. What we did, let's go through the method. We had this, and we differentiate with respect to x, and we get the differential with respect to y. We integrate, so we go down and come up in y, go down in x, come up in y. Then integrate y to get this bottom function. This guy here. The first one we got. Then we do the same thing with this. We differentiate that and come up with this guy. And we get it in terms of v and x. This guy here. And then the last thing we did was compare functions. This is coming to both good. This guy must therefore be this guy. And there is no equivalent one there for that. So that means this guy is equal to 0. So our function is that. And lo and behold, if you remember when we put this up, you'll see that it's actually the function that we had before. Now I'm going to rub. I'm going to put him in.
So this is the Cauchy-Riemann method or something, right?
Yeah, this is, I'll explain to you. This is given one part of an analytic function, the real part or the imaginary part. Can you find the corresponding part given that it's analytic? So you don't know what v is. You don't know what v is. That was a mistake, man. But it verified. I can verify it. So even if I give you the answer, it's still the same method. It only means that now you know the answer.
Yeah, but it was helpful because we get to see that it really works.
That's why, and your teacher Anthony and Kwame is appreciative of good teaching. Sometimes you make a mistake, and the mistake works out for you.
Yeah.
In a matter, wow, it's amazing.
It worked out perfect for me.
Yeah, man. You actually could see that this was the function. We did everything else. Now, if I get this, I can verify that. Now, let's see. Now, this is the part that I didn't prepare. The part that I did, they're always asking you in questions,
in Cartesian form,
this and this.
In Cartesian form.
I'm going to in Cartesian. Whoa, I don't know. I don't know. I have an idea, but I don't know. And sometimes it's good that you don't know. With really advanced students, it's good that you don't know. Because you're forcing them to think. You're not giving them everything. Z is equal to x plus iy. I always write it like that. I don't know why. But then when I do the functions, I put the function in front. I don't know. And this is to the power cubed. And these are all to the power cubed. So, consider that. And this is to the power cubed. We have Pascal's triangle. We have now consider you do that. Expand that in Pascal. Remembering that I squared is equal to minus 1, I cubed is equal to minus I. All right. Same thing is exactly the same thing as this, but you gotta do this in your head, man. This stuff's gotta be done in your head. This Pascal triangle in your head, to the fourth row, you should have it in your head. I know it sounds bad, but come on, man. You gotta, this is. You should have that in your head. It's like you're fixing a car, and you know that there's certain wheels, certain vehicles, or certain lug nuts that are a certain size. You don't have to think too hard when it's doing like that. And it only comes with some practice, brother. All right. So this guy is x cubed. That's iy plus 3x squared I plus, now that I squared becomes minus, that's a minus sign. And that's 3xy squared. And the I cubed is minus I. So minus I. And then we compare, we have x minus 3xy squared plus 3x squared y minus y cubed I. So this implies f of z is in fact z cubed. Now, you know, when I talk to you, Anthony and Kwame, I know Kwame might be thinking, why is it always referring to teaching techniques and tricks? Sometimes knowing the answer can help your students see where you're going. You know, they're afraid, you know, they're scared out there with you. And if you can show them that the world is not too bad, then you can make progress. I'm going to make a question.
Sir.
Yeah?
I'm trying to... Alright. That's trying to connect in my mind. Express f in terms of z. Why did we use a cube again?
Because the highest power of z of x was cubed, and all these powers added to 3. So our first port of call was to go along that route.
Okay.
I'm going to build another question. All right, let's move to another question.
So basically, you just figure out since the highest power of x is z, then you want to verify. You just think, okay, all right, Pascal triangle, raise it to the third power, and that will be.
And see what happens. It might be all right. I want to do another one. I'm going to do another one, and see if we can. I'm going to make it off the top of my head. Watch. The reason why I chose Z cubed because X, if you were given this question, in years gone by, they would have said, they would have given you a hint. They would have said, by considering the powers of U, powers of X and Y in both U and V, deduce that f of z is z cubed.
So basically, these questions, let's assume